This will be geometry lesson 6.3, and this lesson deals with more of parallelograms, more of the parallelograms which are quadrilaterals that we have that we will deal with in the next couple chapters. The first type of special parallelogram is a rectangle, and now we have all these properties on our shapes, so we can transfer these over, and also transfer over all the little symbolism that we have on the shape, because that's what I'll be looking for when we do our hierarchy quiz, meaning that opposite sides are parallel, they're congruent. On a rectangle, all four angles are 90 degrees. The diagonals are of equal length, and they are bisected. So this part equals this part, which equals this little part, which equals this little part. All right. The three main properties that I want you to have is that, hey, all properties of a parallelogram. This is a parallelogram. It has everything going on in a parallelogram is going on here. Now, the main thing that sets a rectangle apart is that we have four right angles, as well as another important one is with a rectangle is that the diagonals are equal length, and we can find those diagonals using the Pythagorean theorem. Okay, so again, might want to be something you note there. That's something that we've done, we will do, and we will do again next chapter. Right? For a rhombus, here's all your symbolism for a rhombus, and here's your four properties. All properties of a parallelogram, because it is a parallelogram. We have four congruent sides. That's the number one thing that sets it apart from a regular from a regular parallelogram. The diagonals are perpendicular. That's what that means. The upside down T is perpendicular. And then the diagonals bisect the vertices, meaning that when I draw a diagonal down here, if this whole angle here is 60, it actually cuts that into two 30-degree angles. And if this is 60, this angle up here, all the others should be 120. Well, it cuts that into two 60s. Now, you can pause the video and you can copy down all these symbols and all the symbolism and all the properties onto your sheet. That way we have it again. Right? And then square, all the opposite sides are parallel, opposite sides are equal, all 90-degree angles, diagonals are equal, diagonals are perpendicular. So it has all the properties of a rectangle and a square. And then on top of that, here's the main thing. It has four equal sides and four right angles. Okay? And then the diagonals are congruent, and we can find those using the Pythagorean theorem again. Right? Alright, so you can copy those problems down, and you might want to jot everything down here. That way when it comes time for the hierarchy quiz, you guys are ready to roll on that. Let's run through some examples. Now here's some reasoning problems. So what we need to do is we need to name the shape, and we need to name these as specific as possible. And then we have to explain why real quick. Now, number one, what we have here is we know that this angle is equal to this angle, and this side is equal to this side, and this side is equal to this side. So what we can do is we know that's a quadrilateral, but more specific, we can call this a rhombus because opposite sides are congruent. So we would call this a parallelogram, and our explanation would be that opposite sides are congruent. All right? Now, if we go to number two, if we look at this, 90, 90, 90, you could take a wild guess this other angle has to be 90 as well. Remember, there's 360 degrees in there. So we could do 90, 90, 90. Now, if we look at this guy, we can call this a rectangle. Now, our explanation for that is now we don't know about the sides or anything, but we do know that we have four right angles, so that would be our explanation there. Four right angles. Now, we need to remember that when we are explaining ourselves here, we need to explain with what's given. On number three here, I can't say anything about the sides. I don't know anything about the sides. Nothing was given, so I can't say that. But what we can do is we can look at this. We know that this angle is equal to this angle, and this angle is equal to this angle. So that narrows it down. It's more than a quadrilateral. It's a parallelogram. Now, can we go to rectangle with this guy? No, we'd have to know that that's 90, and we don't know that. Can we go to square? Well, I don't know. Or rhombus? I don't know if all those sides are equal. So we can't go to a rectangle. We can't go to rhombus. So we most definitely can't go to square. But what we can say about that is that it is a parallelogram. Explanation-wise, we're going to say opposite angles are congruent. Next set, notice I skipped 4, we'll go to number 5. Number 5, what we have is we know that all four sides are 5. Okay, well, if you look at your shape, what's the property that states that all four sides are congruent? Well, it's a quadrilateral, it's a parallelogram, it's a rhombus. Now, what we need to ask ourselves is, can we go further and call this a square? Well, we would need to know that that's a 90-degree angle. And do we? No, we do not. So our most specific name for this is a rhombus. Our explanation for that is that we have four congruent sides, so it has to be a rhombus. Now 6, we have this side equals that side equals that side. That's right, that's right, that's right, that's right. So what we could do here is this guy is a square. Explanation: 4 congruent sides and 4 right angles. Alright, now let's go to 7. 7, if we look at this, we know that this is 110, 110, and this is 70. Now we can do our 360 degrees and start go 360 minus 110, minus 110, minus 70, and we would find that this guy is 70. Now, because we know that these two are equal and these two are equal, we know it's a parallelogram. We know it's that. Now what we have to look for is, can we go further and name it a rectangle or a rhombus? Okay. So if we look at this, can we call that a rectangle? Well, obviously not, because these aren't 90, but can we call it a rhombus? Do we know all the sides are equal? Well, in a parallelogram, opposite sides are equal, so this side would be equal to this side would be equal to this side. So could we call that a rhombus? You betcha. Now the reason we can call it a rhombus is because we have 4 congruent sides. Alright, I'm going to skip 4 and 8. Let's go to the next one here, and we'll look at some of the problems on the back here. Find the variables in the following shapes. So now if we look at this, this guy is a rhombus right here. This is a rhombus, so if we look at this, if this is a rhombus and you pull out your rhombus shape, you will know that this is a rhombus. We know that the diagonals of a rhombus intersect at 90 degrees. They're perpendicular, so that x right there has to be 90. Now what I like to do is, when I know some things in a shape and I can find some other things using those values, I'm going to go ahead and do that. So what I'm going to do is, I know that this is 20, I know that this is 20. Now that doesn't really help me find anything. Okay? But because this is a rhombus, this is 20, this is 20, this guy's 20, and this guy's 20 over here, that really makes my equations pop. There's one right there. I know that that side with 5y plus 5 has to be 20. Okay? And then we can solve that real quick. Minus 5, minus 5, 5y equals 15, y equals 3. Now I also know on this guy that, hey, this guy over here is another equation. 3z minus 1 equals 20. We add 1, we get 3z equals 21. And you divide by 3 and you find that z is 7. So we know z is 7 and y is 3. Right? Now if we look at number 10, same process. Now what we give here is, we're given that this is a square. Now because it's a square, we know that all these angles are 90 degrees. We should know that. And because it's a square, if this is 10, we know that all these other sides are 10 as well. So to me, here's one equation. We know that that side, that angle, that's 3x, should be 90. We also know that that side with 2z plus 4, it should be 10, because all of the sides are 10. Now remember, we can't add side lengths up to 180 degrees. You can't do that. And we always need to find something to equate side lengths to, which is not 180 degrees or 360 degrees. And we solve that. We divide by 3. Divide by 3, we know that x is 30. Okay, we subtract 4, you get 6. You divide by 2, you get z is 3. Right? Now, for y, what we need to look at for y, we go back up here. Now, I know that this side is 10, so I'm going to cover it up that 2z plus 4. I'm going to put a 10 right here. Oh, now what I'm also going to do is, I'm just going to look at this part right here. We know that this is 10, this is 10, this is a right angle, and that is my hypotenuse. So when we set this up, we can go 10 squared, a squared, plus b squared equals c squared. I'm going to go c squared, sorry. Or y squared. Oh, this is y squared. So that's 100 plus 100, which is 200, equals y squared. And we square root both of those. You take the square root of 200, and it's 14.1. So y is approximately 14.1. So that diagonal is about 14.1. Right. Next problem, let's look at number 11, the parallelogram. Now a little bit of a review here. If we look at number 11, now again, I know something in here. I know that this is 110, so what I'm going to do, I know it's a parallelogram. I'm going to write what else I know now because of that. If this is 110, this guy over here is 110. Now the other two would be 180 minus 110, which is 70, and 70. Now because of that, boom, there's one equation right there. So 2x equals 110, divide by 2, and x is 55. The other equation that we have right off the bat now is that, hey, this side right here, that angle right there should be 70, so we go 3y plus 10 equals 70. Subtract 10, you get 3y equals 60. Divide by 3y is 20. Now for z, if we look at z, we know that these two sides, here's a z and here's a z, we know that those opposite sides in a parallelogram are equal, so your equation for that one would be 4z minus 5 should equal 2z plus 13. Alright, and then it's a two-step solve. Minus 2z minus 2z. Same time we can add 5. Add 5. So that's Gandhi, and what we're left with is 2z equals 18 divided by 2z is 9. Okay? So that's the process we do that. Now on 12 we can do this real quick. We know that that's 8. There's your equation. Y is 2. If this is 6, this side over here is 6, those are equal. So add 4, 10, divided by 2, 5, so z is 5. Now the one I really wanted to look at was the last part of this, is finding y. So now again, if we look at that, we see this guy. I see a right triangle. Now within that right triangle, I know that this is a right angle. And this is my hypotenuse. So when we set this up, it should be 6 squared plus 8 squared equals x squared. That's 100 equals x squared. Square root x is 10. Right? So the ideal problem now, Connor is designing a trailer for his four-wheelers. It will be a rectangular with dimensions 6 foot by 12 foot. What will be the diagonal length? So remember, the I is directly in your question. What will be the diagonal length? And you can just copy that right out. Copy that right out of the word problem. And again, what will be the diagonal length? Capital letter, question mark, ready to roll. D, define what you know. Now in this drawing, we're actually talking about a picture, so we're talking about a rectangle. So I'm going to go ahead and draw a rectangular trailer here. Okay, so there's my rectangular trailer. Now what I know is I know that this is 6 feet, and I know that this is 12 feet. Now what Connor wants to know is he wants to know that diagonal length. Now, to calculate this diagonal length, we are going to use the fact that this is a right triangle, and this is what we're trying to find. Now, how do we find the third side of a right triangle? That's Pythagorean theorem. So our E, we'd probably want to jot that down. A squared plus B squared equals C squared. Now, if we look at this drawing, A, B, C, that X is my hypotenuse. The diagonal is always the hypotenuse of that right triangle. So we'd have it set up 6 squared plus 12 squared equals C squared. So we would go 6 squared plus 12 squared is 180. And then we would square root the 180 and 13.4. So we find that that side is 13.4. Now L, label it completely. So we would say the diagonal length is about 13.4 feet, period. Right? So that's the way we do the ideal process. I'm not going to do another one with you, but the two that you have at the bottom of there would be homework as well as the Math Excel. So if you do have any questions, make sure you come in and see me, and good luck.